In this video, I'll demonstrate how to create the schematic for an inverting amplifier. This video builds on the setup covered in the previous tutorial, Fusion 360 Electronics project. Please watch that video first before continuing. You'll find the link in this video's description. Start by launching Fusion and opening the BME 313 project. If this page doesn't appear, go to File, New Electronics Design. Click here to begin a new schematic. This blank workspace is where you'll draw the circuit. First, ensure the active library is BME 313. If it's not visible in the drop-down, open the Library Manager. Go to Hub Libraries and enable the BME 313 library. Close the Library Manager. Next, place the title block. Double-click the title block symbol, position it on the sheet, and click to place it. A second copy appears automatically. Press Escape or the Done button here to stop placing additional blocks. The title block defines the schematic area and ensures a professional layout when printed. Now add the components for the inverting amplifier. Begin with the operational amplifier LM358, which has the same pinout as the LM353 used in the lab. The dropdown shows both through-hole and surface mount versions. Through-hole parts require drilled holes on the PCB, surface mount parts do not. For this design, choose the surface mount version to save board space. Double-click to place the first op-amp unit labeled as A. Press Escape to avoid placing the second unit labeled as B, which we don't need. Next, place two resistors. Open the resistor list and choose the 0805 surface mount package. The package dimension is 2 mm by 1.25 mm, and it is a popular size that is easy to solder by hand. Double-click to place R1 and R2. Add connectors for input and output using 2-pin connectors. One for the signal input and one for the output. Then place a 3-pin connector for the plus and minus power supply. With all components placed, rearrange them for easier wiring. Flip connector J1 so pin 1 faces R1. Right-click, select Mirror, then press Escape to exit mirror mode and reposition it. Rotate J3. Right-click, select Rotate. Then press Done so you can move it without rotating again. Next, bring in the op-amps power pins. Since LM358 contains 2 op-amps, the power pins aren't shown automatically. Right-click the op-amp, select Invoke, select the power symbol, and click OK. Move the power pins close to the op-amp. Shift text labels slightly to improve readability. Now add the power supply symbols. Use VCC for the positive supply and VDD for the negative supply. Follow the IC specifications and connect VCC to pin 3 of the connector and pin 8 of the op-amp. Then connect VDD to pin 1 and pin 4. Add ground symbols. Use A ground or analog ground for all analog circuitry. Digital circuits use D ground, but this design is purely analog. Click AGND and place it at the power connector, input connector, output connector, and the op-amp. Assign resistor values. Right-click each resistor, select value. Set R1 to 1 kΩ and R2 to 26.7 kΩ. Now wire the circuit. Move components slightly to reduce crowding. Then use the net tool to connect the input to R1 to the op-amp's negative input, R2 as the feedback resistor, and the output node. Connect all ground and power pins. Click Done to close the panel. Note that identical net names are considered connected even without drawn wires, useful when routing becomes difficult. Once wiring is complete, save the schematic. Name it Inverting Amplifier and store it in the BME 313 folder. The title block will automatically update with the file name, version number, and creation date. To print the schematic, type Print in the command bar and press Enter. Choose Print to File, PDF. Select the output folder, for example, Downloads, and confirm the settings. Click OK. In your Downloads folder, you'll find Inverting Amplifier v1.pdf, which contains the completed schematic. Open the PDF file to view the schematic. This is the end of the demo. The schematic design process can be summarized as follows. First, create a new Fusion Electronics design project and start a new schematic. Begin by placing a title block on the schematic, which defines the drawing boundary for the circuit. Next, place the required components from the project library onto the schematic and arrange them logically to reflect the signal flow from left to right. Then, use the Net tool to create the electrical connections between components. Finally, save the schematic design. The completed schematic contains essential information, including component packages and net connections, which are required for the subsequent PCB layout design. It also stores component values and, when available, associated SPICE models for circuit simulation. In the next video, we'll walk you through designing a printed circuit board based on the current schematic. If you found this video helpful, please like, share, and subscribe for more content.